Of course, let's now use the idea of derived state in practice. And in particular, we now want to calculate our statistics here. So calculating the number of items on the list, how many we already have packed, and then the percentage of that. Now, if we think about these numbers, for example, the number of items in the list, that number can be directly computed from the items array itself, right? And so derived state is perfect for this. But before we use derived state, I will show you how not to do this. So the way we should not do it is to use state. So let's say we created a piece of state called num items and then set num items. And by the way, you don't need to write this code right here. All right. So this is just to show you how not to do it. So initially we start with 0 items. Now the problem with this is, as I said before, is that we now have to also update this piece of state. So whenever, for example, one new item is added, besides setting the items, we also need to make sure to increase this number here. So set num items, and then the number, and then num plus 1. So with this, we would ensure that these two pieces of state stay in sync. But that's of course a lot of additional work that we might forget to do, and also it can cause multiple re-renders, where at least one of them here is unnecessary. Now in React 18, these should be batched, so these two should happen at the same time, but more about that later. But in any case, this is a terrible idea. So instead, we can just define a new variable called also num items, but we can simply derive it. So we can calculate it based on the items array. So that's simply items dot length. And so this works because as soon as the items are updated, so as soon as this piece of state is updated, the component will re-render. And when the component re-renders, that means that the function here is called again. And therefore, then this piece of code here will run again. And so if a new item has been added, then now the item state, so this array is different, and therefore the length will also be different. Now this num items variable, we actually don't need it right here in the app component, but in the stats component. So this one right here. So we have two options now. The first one is to keep num items here and pass it as a prop into stats. But I think what makes more sense is to actually calculate this state here, so this derived state, inside the stats itself. Also because we will actually calculate 3 values, and so if we were to calculate them here, then we would have to pass 3 props, which doesn't make a lot of sense. So let's just cut that from here and paste it here into the items. Well, actually no, that's not correct. Want to paste it right here. But now as soon as I save this, we will get an error, right? And so the reason for that is that now, of course, we don't know. So this stats component doesn't know anything about what this items is. So we now have another component that needs the item state. So we just pass it down as a prop. Just like we passed it also into the packing list. Now, of course, we need to accept that prop down here. And so this solves the problem. And so here we can now already use that value. So you have num items on your list. And so yeah, indeed right now that's 0. But if I add some socks here and maybe a shirt, then you see as soon as we add new items here, the array grows. And so then this number here also gets updated. So watch what happens when I hit enter, and immediately this changed from 2 to 3. Let's just quickly remove those console.logs there. So that's much better. And so now let's derive our other pieces of state. So of course, this one here, so the ones that are already packed, and the percentage both depend on the items themselves. So number of packed is simply the items array filtered by the items that are already packed. So item dot packed. So that's a new array. And so then we can take the length of that one. So you have already packed number of packed. And so that immediately becomes 0. But then when we mark one of them as packed, beautiful. So 2 and then all of them. Great. And now finally, just the percentage, which should be pretty easy. So that's just the number of packed divided by the number of items times 100. And then let's grab all of that and round it. So math.round. And so here then we can replace that. Nice. That also works. And now it hits 100%. And in that case, so whenever we have 100%, I would like to display an entirely different message here. So telling them basically that they are done. So watch what happens here in the demo. Yeah, that's it. So let's write that here. And so for that, we need some more conditional rendering. So actually, we will just conditionally define what is here inside this M element. So let's enter our JavaScript mode and say that whenever the percentage is equal to 100, then the content should be this string right here. You got everything ready to go. Now let's add a plain emoji here as well. And now else. And so let's move that here. And so now instead of this text that we had here, we now need a string. And so let's make a template literal here. And then we need to add, of course, these. And in case we didn't want to create this template literal, we could, of course, also have simply rendered one EM for each of these cases. Now this looks not correct. Maybe it's because of this right here. Yeah, but it looks as though it works, even though we are in the wrong app. But here we already have our correct message. Let's uncheck one of those. And now you have 3 items on your list. Great. Now let's remove this one and this one as well. And so now we have already packed 0. And also in this case, I want to display something else as well. So also another message. So if this is the case, if there are not even any items in the array, then it's not even necessary actually to perform all these calculations because they will just be 0 anyway. So what I want to do now here is to show you a good use case of an early return as conditional rendering. So what we're going to do is to say if there is no items dot length, then simply return. So let's return a paragraph with the class of footer, and then here also an EM, and then start adding some items to your packing list. And again, some nice emoji here, like this rocket. And so now let's reload this here so that we then have no items. And so yeah, here we go. Now here, the class name is not footer, but stats. So basically the same as here. And so yeah, then we got this. So this text that we defined right here, so this paragraph. And again, that's because in this case, it doesn't even make sense to then do these calculations. So if there are no elements anyway in the array, then don't even bother with all of this here. Now, in this case, of course, it would have been no problem to still do these calculations as they are not a lot of work. And we could then have some conditional rendering in here. But this was just to show you that the option of an early return is sometimes also nice. So it's also quite legible here, if you ask me. So when you arrive at this component, maybe you have never seen it before because one of your coworkers wrote it, then you can right away see that if there are no items, well, then just return this. And in all other cases, then perform the rest of the logic of the component. Great. So hopefully that made sense. And so next up, let's see another use case of derived state, which will be to implement this sorting functionality here. So that will make this application look even more real life. And so I think this is going to be really fun.